talk about the quadratic formula. So I know you've all heard of it. I know you've all used it, but I know you haven't had some of the experience that we're going to do today with it. Okay, so just like when we did square roots, where, let's come up with an example from our homework. Let's see. From your homework problems, we had something like, and I'm not exact on this, x minus 2 squared, what was it? Plus minus 18. You guys remember this one? Minus 18, we did it in class, equals 80? 19? Yeah. And I don't remember if that's right, but it was similar, correct? And so what did we learn from that? We can actually do that in our head. Right? How? How could I do that in my head? No, it had something here. Allison? When you add the 19, it's 99. So how could we solve that in our head? The square root of 99 is about 10, right? A little bit smaller than 10, like 9.9. Then what do we do with this part? Okay, you guys want to solve it all the way through? X equals positive 2 plus or minus the square root of 99. And then we talked about, remember how we talked about this? That means I would be over 2, right? And then this part of the equation, this part right here, is just telling me start at the axis of symmetry and go to the right that many and to the left that many, right? Remember we had symmetry? We investigated that and found that to be true. So I would start at the axis of symmetry and I would go over almost 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, almost 10. So 11 point something, 11.9. And I would also go back 1, 2, 3, 4, 5, 6, 7, 8, 9, almost 10. And that would be negative 8.9. No, it was 7.9. It was, yeah. So the example we did was x minus 1. And then so you guys saw that you actually have your axis of symmetry right here already. This is reviewed from yesterday. Oh, I just screwed it up. So when I look at this, I say, oh, well, my axis of symmetry is actually 2. And I'm going to go up or go over in the positive direction, almost 10, and go in the negative direction, almost 10. Well, it turns out that quadratic formula kind of does the same thing. So I'm going to go kind of out of order of my slides. This part describes the center of the roots. This part right here. Negative 2 over 2 times 1. Let's investigate this. I actually factored this one out. It's negative 2 plus 4. If I want to know my zeros, I would just say, okay, if I set this equal to 0, it would be x equals positive 2. If I set this equal to 0, it would be x equals negative 4. I plotted those, and we know that I can just go right between and find my axis of symmetry. But if I didn't know my zeros, if this wasn't factorable, I could use something called negative b over 2a. It gives me my axis of symmetry. And it happens to be part of that quadratic formula. This part of the quadratic formula tells me something about my roots. Because since it's the plus or minus, isn't it saying I've got my axis of symmetry? I've got my axis of symmetry, and then I'm going to go plus and minus in the positive and the negative direction. Isn't it the same thing that we were talking about yesterday? But this actually tells me something very specific about my roots. It doesn't just tell me which way to go in the positive and the negative direction. There's something else there that I want you to investigate. Amanda, put it down, please. Close the cap. Okay, so I'm going to do the first part of the investigation with you, and then I'm going to ask you guys to do the other three. And I'm going to ask you to find the discriminant, but we're not going to talk about what it does until we're finished with the investigation. I'm going to give you about 15 minutes to do it. So I'm going to do very little teaching today, and you guys are going to do a lot of working things out together. So let me do the first one. Let me get your absolute attention, no writing, no nothing, just watching what I'm doing. Okay? Because on the first one that I'm going to do, I'm going to go all the way through it. I'm going to use all the pieces of information I can possibly use. So here we go. Is 4x squared plus 8x plus 4 equals 0 factorable? I know it's factorable for sure. And this can tell me why? Let's hear it. Lucas, you want to try? You could divide them all by what? They're by 4. You're absolutely correct. They all have a GCS. So I know I can at least do that, right? So let me do that. I'm going to pull out a 4, and I'm left with x squared plus 2x plus 1 equals 0. So now I try and factor it. I know that this is going to be x and x, and that has to be 1 and 1. If I put 2 plus signs, does 1x plus 1x make 2x? So it factors. So I just lucked out on this one. Rain, can I have you sit up, please? Jamari, can I have you stop doing whatever you're doing and pay attention? Okay, so I'm going to go ahead and plot what I know. Well, if x plus 1 is set to 0, x would equal -1. Same thing over here, x would equal -1. So I only have 1 0. What do I know about that when I only have 1 0? It may be my vertex, but I know for sure it's my axis of symmetry. Let me make this a little bit wider so we can actually see it. I know for sure it's my axis of symmetry because it's in the middle of the roots. There's only one root, and it's in the middle, so it must be my axis of symmetry. Is there anything else I know from this graph? Sorry, not the graph, but the function. I know my y-intercept. Good. My y-intercept is right there. 1, 2, 3, 4. So actually, this one graphed pretty nicely. I didn't have to even look at anything over here, right? So I'm going to go ahead and investigate this now just to verify what I've already done. So the ones that you guys are going to do, you're going to get this exact one, and then you're going to do 3 more. One of them is going to be factorable, only one of them. So one of them you'll be able to do easily like this and be able to check your answers. And the other 2 you're not going to be able to factor, so you're going to have to be able to use all kinds of different pieces of information that you have. Okay? Does that make sense? Okay, so let's keep going. And I think this is a really good activity because I think guys are still struggling on finding the vertex. Would I be correct in saying that? Yes. I think I would be correct. All right, so I'm going to go ahead and get started with my discriminant. And of course, always happens, like right here, huh? My pen runs out. Okay, so x equals -b all over 2a. My b is here. My a, what color did I do it? Is here. And my c is here. Right? So I've got them all color-coded. So let's put my b in there first. That would be +8. And my a is going to be 4. And if I simplify that, I get negative 8 over 8, which is negative 1. X equals negative 1. Is that consistent with my graph? Yes. Now let's use x being negative 1 to find my actual vertex. And we're trying to find my vertex. I already have my x part of my vertex. Now I just need my y part of my vertex. So I'm going to go ahead and plug it back into this part right here. Let's use red. That's not red. I can plug it in here, or I could plug it in here. It doesn't really matter which one I plug it into. I think it's easier to plug it into the factored one. And I didn't even plug it to the right one. It would be this one right here. That's the easiest one to do. But if I didn't have that, I could put it back into this top one right here. So I'm going to go ahead and do that. I've got 4. This is to find my y. 4 times x plus 1 times x plus 1. Let's see what color. I'm running out of colors that I can use. I'm just going to do negative 1 and highlight. Negative 1, negative 1. Where did I get that negative 1 from? My axis of symmetry, right? So I get negative 1 plus 1 is 0. Negative 1 plus 1 is 0. So I'm just going to get 0. That looks like a 10 now. 0. So my vertex is indeed at negative 1, 0. That's consistent with my graph. The last thing I'm going to do is find my discriminant. Let's see what happens. So in order to get my discriminant, I need my b to be squared minus 4 times my a and my c. My b is 8, correct? My a is 1? No. 4. And my c is also 4? So when I put all of those in, I get 64 minus 4 times 4 is 16, and 16 times 4 is 64 equals 0. Let's talk about that. The discriminant is 0. Discuss with your tables, what do you think that has to relate to the graph? Remember I said it tells us about our roots? I got 0, but I don't have 0 roots. I have 1 root. Don't I? I have 1 root. Talk with your tables for a second. What do you think the 0 means? Okay, so weren't we talking about with our homework last night that this is the axis of symmetry, and this tells me where to go in the positive direction and in the negative direction. So if it's 0, am I going to go in the positive direction or the negative direction? No, which would be consistent with my graph. I start at the axis of symmetry, and am I going to go to the right or to the left? I'm not. So if you get a 0 underneath here, you're only going to have 1 root because you're not going in the positive or the negative direction. Does that make sense? Yes, Marty. So if the vertex was 1, positive 2, we're going to be investigating stuff like that right now. So I want you guys to do these graphs, take your time, and talk them through. I want you to be able to do all of these things except, like I said, 2 of them you can't factor. But I want the discriminant, I want the axis of symmetry, I want the vertex, I want it graphed, and I want the zeros. So do as much as you can, okay? All right, I'm going to pass that out right now. Get going. All right, so let's look at this next one, and I'm just going to go real quick, and I'm going to go through what I know. Is this one factorable? This is the third one.
Yes.
Yes. So this one was factorable. I'm going to write y, because if I'm going to graph it, isn't this really y? Okay, so this is x, and this is x, and 8 is 4 and 2. Both of them have to be negative, because this is negative 6x. Then I say to myself, if I set this equal to 0, x is going to be 4. And if I set this equal to 0, x is going to be 2. So I have my zeros already, 2 and 4. And since I have my zeros, I know my axis of symmetry is in between them. And I have one more piece of information. I also know 8 is my y-intercept. If it's 3 away from my axis of symmetry, then it's 3 away over there. The only thing I need is my vertex. So I'm going to go find my vertex. And I'm going to use this formula, which is part of the quadratic formula. So my b, I would suggest you use parentheses. That will help you out. My b is negative 6. Here's my b. Here's my a. And here's my c. Okay. So if my b is negative 6, Lucas, I can hear you whispering behind me. This is 1. So when I find this, I have positive 6 all over 2 is going to be positive 3. That's my x. That's what I did originally. X equals, I'm just going to move all of this down a little bit and make room to find my vertex. I can't get my vertex until I have my y. I need x comma y. I have the x, it's 3. So I'm going to plug it back in to my actual formula. I can plug it in here, or I can plug it in here. It doesn't really matter. So I'm going to plug it into this one. So my x is 3 minus 4 times 3 minus 2. That's going to give me my y. You see how it's helpful to write the y there? Sorry, I want you looking up here. I want pencils down. 3 minus 4 is negative 1. Some of you got confused on your test, and you added. Okay, so no more shuffling up here. This is where I got frustrated last class. I started shuffling and writing. Pencils down. Negative 1 times 1 is negative 1. You're not paying attention when you guys are writing. When you're writing, you're doing this. You're going up, down, looking up, down. I want your full attention right now. Okay? That's so much better. Thank you. So I found negative 3. Why did I get negative 3? That's wrong. Negative 6 over 2a. It should be 3. Oh, no, it's right. 3, 1. I don't know what I'm thinking. 3, negative 1. That's perfect, right? Is that consistent with my graph? It is. Hold on. Then, my last part is I want to find my discriminant. So b squared, change my color. I have b squared minus 4ac. My b is 8. My a is 4. Or no, is it 1? It is 1. My a is 1, and my c is positive 8. Put that all in there. I get 64 minus 32. What's 64 minus 32? C is 6. Negative 6. Thank you. negative 6, which would make this 36 minus 32 equals positive 4. All right, we're going to save that. We're going to think about it in a second. I'm going to do the other two. This one, as we figured, was not factorable. But there is one thing we can get from it. We can get that it has a y-intercept at 10. So I go over here and I find the vertex. First, I'm going to find the axis of symmetry, though. So I have negative b all over 2a. This b happens to be positive, and my a is 1. So I get negative 6 over 2, which is negative 3. Negative 3, 1, 2, 3, is my axis of symmetry. It's not really a point, right? It's just my axis of symmetry. 1, 2, 3. So now I have another point up here. Since I know my axis of symmetry and I know that I'm up here at 10 on my y-intercept, and that's 3 away from the axis of symmetry, I could go 3 more away on the axis of symmetry. But I'm not done yet because I still haven't found the vertex. All I found was the x part of my vertex. So the x part of my vertex is negative 3. I've got to find the y. So I'm going to plug it back in here because this is my y. So I have x squared plus 6x plus 10. If I substitute negative 3 in there, I get positive 9 minus 18 plus 10, which equals 1. When I go over to negative 3 and go up 1, there's my vertex. This one doesn't even touch the x-axis. Now let's look at the discriminant. So my b is 6 squared minus 4. My a is 1, and my c is 10. 36 minus 40 is negative 4. So the first one we did, the discriminant was 0. The very first one we did, the discriminant was 0, and I had 1 root. Right? The second one we did, I had a discriminant of 4, and we had 2 roots. The third one we did, I had a discriminant that's a negative 4, and I have no roots. I'm seeing people shaking their heads. Do you see any type? Let's do one more and see what happens. Okay, x squared minus 5. I see a lot here. I see a whole lot. It may not be factorable, but what I know about square roots is, couldn't I just put this on the other side and take the square root of both sides? Or I could just look at it like it's a parent graph, right? And shift it down 5. 1, 2, 3, 4, 5. Because isn't that the y-intercept? That has to be the y-intercept, and I know that it's not shifting over because of this. Hold on a second, guys. So it just looks like this. I'm just going to do the discriminant and we'll be done, because I already know my axis of symmetry and I already know my vertex. I don't even need to do those. So b squared, what's my b? 0. I don't have a b. There is no middle term here. Minus 4, what's my a? 1, and what's my c? So I get negative 4 times negative 5 is positive 20. This discriminant is positive and it has 2 roots. This discriminant was negative and it had no roots. This discriminant was positive, it had 2 roots. And this discriminant was 0 and it had 1 root. So that should, we're going to explore that more. I'm going to pass out your, and I'm going to pass out your homework at the door. Listen up. All I need you to do is see if it's factorable. If it is, factor it, and give me the discriminant, and we're going to go over it on Monday. Understand? That's all you have. You don't have to find solutions. unless it's factorable. If it's not factorable, you just find the discriminant and stop. Hi.
Watch out, watch out.
Have a great weekend, guys. Am I still recording? Miss Wiz, can you stop my recording?